All right, so the test is going to be on Monday. All right. So I figure the best way to review for a test is to go over the quizzes, right? Because all the quizzes cover everything from the chapter. And the test may not be exactly the problems, right? You've had me before, you know how that goes. Sometimes you do see the exact problems from the quiz, sometimes change them up a little bit. But it's basically the same exact style, okay? There should be. Have you ever taken one of my tests where you were like, Mr. Hamrick, you never went over this. You never told us this would get me on here. No, I don't think so. If you did, that was probably your fault because you weren't paying attention, okay? Every single test I give you is stuff that we have gone over in homeworks, on quizzes, we've answered questions on it, and all that kind of stuff, okay? So, because I always hated, I remember on several occasions I'd take a test and I'm like, what in the world is this, you know? And they're like, well, you should know how to do this. You did this a little bit, but this is a little bit harder, but you should, you know. I was like, what? So anyway, but on the other hand, I think it's good for you to have a few surprises, but anyway, I'm not going to. All right, here we go. Let's go through some of this. This is from the first quiz.
You're recording this?
I am. I said I was. All right, it says the domain is all the integers. That's a key to this. Whoops, that's not going to write. Let's do this. All right, let's try that again. Okay, the domain is all the integers. Okay, what's an integer? Just any number? Okay, its number is not a fraction. Okay, I guess you could say that. The way I like to say it's probably not like the official math way to say it, but it's like all the whole numbers plus the negative whole numbers. But that's kind of a contradiction because whole numbers aren't negative, but you get the idea though, okay? So you know what whole numbers are, right? 0, 1, 2, 3, 4, 5, 6, 7. And then the, quote, negative whole numbers would be -1, -2, -3. So nothing in between. So that's pretty important. So greater than -5. So give me a number, give me the first integer that's greater than -5. That would be -4, okay? And then all the way until you get what? Less than or equal to +4. So this is going to go all the way down to +4. So you just list all the integers up to +4. All right, -3, -2, -1, 0, 1, 2, 3, 4. And then you put all the numbers, and then it says the range is 8 more than x. All right, so basically you're just adding adding 8 to all the x values. So what's -4 plus 8? 4. And you keep going, and you get what? 5, 6, 7, 8, 9, 10, 11, and 12. So that's how you do number 1. All right. Now, here's the part. Seemed last year, a lot of people missed this, but you guys seem to get this pretty good compared to last year's class. Even though we went over it just like we did with you guys. So we have to graph this thing. So you're going to graph -4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right there. Oh, I know what we did. We didn't go up 4, did we? Remember I told you on the quiz there wasn't enough spaces because it doesn't go all the way up to 12. So what did I say to do? Make the y's by 2. So the x's are still 1, but we're going to go half as much up. 1, 2, 3, 4. And this would be what? 2, 4. Everybody with me on that? All right, and then -3. Where's 5? Where would that be? That's 2. That's 2. That's 4. That would be 6. So we're halfway in between. This thing doesn't make little circles very well. It kind of scoots off like that. And then what would it be? You go over the next one, go up to here, right? Go over the next one to here. Whoops. See what it does? It shoots that thing out. I don't know why it does that. It's weird. Maybe I got to go slow. That's what it is. All right. And then where? Here. And then here. Then where did it go? Went to 4, right? So this would be here. This next one would be here. And then one more. It would be here. Yeah, there we go. So do we connect a line? Normally we do, right? Normally we connect a line. But on this one, we don't connect the line. Why do we not connect the line here? Because they're integers. They're integers, okay? So if I connected the line, that would include all the numbers in between, okay? Question? Right pass. It's the most dreaded question of all times. Let's go through these a little quicker because there's problems on the other quiz we probably want to hit, I would guess. Domain and range. All right, so the domain are just all the x values. And if they do repeat, don't put them down twice. All right, I think a couple of you did that. I still gave it to you, but you should not. So you're going to have a 0, a 2. See, there's two 2's here. You're just going to put one of the 2's down. And then there's 2 5's. You're just going to put one of the 5's down. So that would be the domain. So you would write domain equals, put it in the braces, put 0, 2, and 5. All right? And then the range, you're going to do the same thing. You should put them in numerical order. Some of you guys did not do that. I did not mark off for it. Some teachers probably would. Because I did tell you when we did these problems to put it in numerical order, didn't I? Yeah, so if you didn't do it, I should mark it wrong. But you're lucky I'm so nice.
Thank you.
Sure. That's an ugly brace, but you get the idea. All right, I'm not going to do the rest of these. The range, if you put them in order, I think it's what? -8, -2, 0, 2, 8. Okay, so that's what that would be. Tell whether it's a function or not. Is this a function? Why not? That's right. 2 goes to +2, and this 2 goes to -2. If you have the same x value go to 2 different y values, it's not a function. Everybody hear that? So if you have the same x value going to 2 different y values, that is not a function. So that is not a function. Right here, look at it. You don't have any repeats, do you? So you don't have any repeats on the x's. Well, the y you do, but for the x's, it doesn't matter if you have repeats on the y's. Okay, only if you have repeats on the x's. Like right here, see, that's enough to make it not a function, but also this. Okay, that's another reason why it's not a function. That goes to 8, that goes to -8, 2 completely different numbers. That's not a function for both of those reasons, okay? But right here, it doesn't matter if, watch, 2 goes to -3, but this one, 8 goes to -3. That's fine. It can be a function if you have that. So sometimes it's a little tricky to keep it straight which one is which, but that's how you do it, okay? Right here, f minus g of x, what is that? That just means you take your f function and you subtract the g function from it. So that's going to be x squared minus 2x.
Hi, did you send Charles' brother down today?
He's not in my class today.
Okay, thank you.
So minus g of x. Here's where you went wrong. Look at the g of x. What is g of x? It's x plus 9. I can't remember, it's been a few days, but I think a lot of people did this. Minus x, what do you think they did? Plus 9, but it's not because you're subtracting that whole entire function. So it's negative x what? Minus 9, all right? And so it's x squared minus 3x minus 9, okay? Got to make sure you keep that in mind. What does this say we're doing? This says we're multiplying the two functions together. So we're taking f of x and we're multiplying it by g of x. So we're taking those and multiplying them together. So I've got x squared minus 2x. That's being multiplied by this g of x, and that's an x plus 9. It's very important that you put them both in parentheses. And you do a little FOIL method with it. Okay, once you do the FOIL method, you come out with x cubed plus 7x squared minus 8x. 18x. Okay? Everybody good with the FOIL method, right? Yeah, you should be. All right. Now, what about these? What's that? It looks like fog, but it's not fog. What is it? It's composition. Composition. So it's f of g of x. That's what that first one says. So f of g of x. Well, you're like, okay, I got that, but that doesn't help me. Well, sure, it should, because what are you going to do? Victoria, you with me? So you're going to take that g of x, and you're going to put it in for what? The f function. So you're taking this, and you're not just putting it into the function, but you're putting it into the x value, any x values in the f function, you're replacing it. You're substituting 3x squared with it. So you're taking that 3x squared and you're replacing that x with a 3x squared. That's the difference between composition. Everybody see that? I think it's always good to write that. That always helps me out a little bit. All right, so the g goes into the f. This is the g that goes into the f function. So it's just going to be 3x squared minus 4, and that's it. That's all you had to do. Not much work at all, if any. This one's g of f of x. So it's g of f of x. Now this time, you're taking the f function and you're putting it into the g function. So this time, you're taking this and anytime you see an x in that g function, you're putting an x minus 4 into its place. So let's rewrite this. So it's 3 times x squared. But what am I putting in for that x? X minus 4. And what are we doing to that? We got to square it. So that's g of f of x. Does that make sense? Now you got to know what to do with this. You can't just go 3x minus 12 and then square that. You got to square this stuff first, and that's a little FOIL method, isn't it? So you're going to have to go like this. I'm not going to do all the work for you. You can do that, but once you do that, you get 3x squared minus 24x plus 48. All right? So just FOIL this. Once you FOIL it, multiply everything by 3, and you're good to go. All right, let's do this one. This one's pretty straightforward. Didn't really have to show any work. All you have to do is just graph it. All right, so -3, that's your y-intercept. So I'll tell you what, let's make this a little bit bigger since we're graphing. All right, so -3, 1, 2, 3, right there. And this, what's that? It's frozen? Oh, man. I should just always... Now I got to figure out how to do this thing. So just because I plug it up, I'll tell you what, I don't know, it's going to take me forever to do that. Let me just minimize this. And I think you know what I'm going to do? I'm just going to turn it off and turn it back on again, maybe. That always seems to work. So hopefully this will work. Let's try it again. Never had so much trouble with a projector as I have since I went wireless. Wasn't my idea. All right. There we go. Let's do that. All right, let's try this. No, just hang on. I'm almost done. If anybody's watching this on YouTube, I'm trying to get my projector to come back on. I think I got it working now. All right, we good now? What's that dumb thing? There we go. All right, now we're back in business. So there's the y-intercept, and the slope is 4 over 1. So we go 1, 2, 3, 4, 1 right there. We just connect them, and you got your graph. It's that easy. Everybody should be able to do that. I don't remember off the top of my head how you guys did on that, but I would think that would be pretty easy. On this one, you had to do a little bit of work for this, didn't you? So what are you going to do? Get y by itself. Isn't that what you would do? Yeah. So let's subtract a 2x from both sides. So I've got 5y equals -2x plus 8. Divide both sides by 5. Divide that by 5. Now, the numbers come out a little ugly, don't they? Plus 8/5. So what's 2/5? Like, if we were going to graph it, how would you know where 2/5 is, or -2/5? What would that be as a decimal? What if it was over 10? It'd be 4, right? So it'd be 4/10. It'd be -0.4. Can you do that in your head? If not, put in your calculator, okay? What about 8/5? 8/5 is 1 and what? 3/5. What's 1 and 3/5? Is 1.6. All right? Everybody got that? So that makes it a little bit easier to graph. And you don't have to be perfect. There's no way I can see if you're at 0.4 or negative 0.4, negative 0.3, or negative 0.5, okay? But just somewhere in there is fine. So forgot the x right there. All right, so what's the y-intercept? It's positive 1.6, correct? So there's 1, there's 2. It's a little more than halfway. If you're anywhere in between the two, I'm good with that. And then the slope, actually you didn't even have to do that for the slope, did you? I'm sorry. My bad. It's just the y-intercept. This is just negative 2 over 5. Now watch what you got to do though. See, I'm kind of in the middle here. So if I go down 1, I got to be in the middle of this one. And then I got to be in the middle of this one. So there's my negative 2. And now I run 5. 1, 2, 3, 4, 5. About right there. And then I connect them and I'm good. So that was a little bit tricky. But really, it's just a matter of where your y-intercept is. We good? All right. Okay, let's go to this one. Just gave this back to you. When do we get out of here? Is it quarter of? Okay, 45? For all you digital people. Okay. All right, let's do these. We might have time to do them all. Oh, this was pretty easy, right? Slope-intercept form. What's slope-intercept form? Y equals mx plus b. Let's make this a little bit bigger now. There we go. All right, so it's pretty simple. Y equals m, which is 5x plus b, or minus 2. And there you go. That's all there is to that one. Just in a matter of seconds, you can do this one. This one took a little bit of work. All right, so it passes through these 2 points. We want it in slope-intercept form. First of all, let's find the slope with this. So how would I find the slope? Yeah, change in y over change in x. That's a nice way to say it, isn't it? Okay, so let's start saying it like that. Change in y over change in x. What does that mean, the change in? What do you do to those, what you just said? Just subtract them, exactly. Excuse me. It doesn't matter what order you subtract them. Let's go to the second one minus the first one. So let's go 9 minus 5 is 4. Negative 8 minus 1 is what? Negative 9. Is that right? Negative 8 minus 1. Yep. So there's my slope. Now, you could do it a couple ways. You could do the point slope form and then change it back into the slope intercept. I'm just going to do it like this. What does this x and this y represent? It represents any point on my line. So I could either pick point A or pick point B because I know both of those points. I'd probably pick the one that looks a little easier. Which one looks a little easier to you? The A, right, the 1 and the 5. So this is my x and that's my y. So now I know my slope already, so I can put 1 in for the x and put a 5 in for the y and then solve for b. Once I get my slope, my y-intercept, put them all together and it's nice and easy. All right, so what is the y on this one? It's 5 equals the slope, which is negative 4/9, times the x, which is just a 1. So do I really even need that there? Not really. Plus b. Add a 4/9. Add a 4/9. What's 5 going to be if I write it over 9? 45 over 9. So 45 plus 4 is 49 over 9. And I'm basically finished all the work. Now I just put it together and make it look nice. So y equals the slope, which is negative 4/9 x, plus the y-intercept, which is 49 over 9. And that is the slope-intercept equation of a line that passes through those 2 points. Okay? Everybody good with that? Yeah. All right, let's do these. Parallel, perpendicular, coinciding, or none. Let's take a look. What are we going to do first? Find the slope, okay? So let's move everything over. So y equals what? 7x minus 5. Do this. Move everything over here. It's also going to be 7x to be a plus 9. I don't really care about the y-intercepts. What do I care about? just the slopes. That has a slope of 7, that has a slope of 7. So what are these two lines? They're parallel. Everybody good? Yeah, most people got that. This one's a little bit tougher because you got to do math is just a little more difficult. Not much though. All right, so let's do this one. Negative 6y equals negative 4x plus 11. See what I did? Took that 4x, moved it to the right side. And then divide everything by what? Negative 6. Divide that by negative 6 as well. So I get y equals positive 2/3 x minus 11 over 6. Now let's do this one down here. So subtract a 3x from both sides. So 2y equals negative 3x plus 9. Divide both sides by 2. So y equals negative 3 halves x plus 9 over 2. You really didn't even have to write that out. Right here you knew what the slope was, didn't you? Right there. And right here you know what the slope is. It's 2/3. Are they the same line? No, because they got different slopes. Is there a relationship between the slopes? Yeah, that's 2/3. This is negative 3 over 2. They're negative reciprocals of each other, so that means they are what? Perpendicular. Okay, easy enough. What about this one? This is already in slope-intercept form, y equals 3x minus 2. This is y equals what? Negative 3x plus 2. So compare this to this. Is there any relationship between the two? There's not. Okay, I mean that's a 3 and that's a 3, but that's really not a 3, is it? That's a negative 3. So they're not the same slope. They're not negative reciprocals. So what is it? None. All right, there's no relationship. They'll eventually cross each other, intersect each other. Okay? And not at a right angle. All right, good enough. Standard form. So this took a little bit of work, so let's do this real quick. Oh, I forgot the M right here. Did anybody notice that on the quiz? See, look, the standard 4. And on my answer key, I put in a little red M, but I never did go back to the computer and change it. I need to do that this time, so next year. But you guys didn't even notice anyway, so there you go. Write the standard form. What's the standard form? AX plus BY plus C equals 0. Right? The A, B, and C all have to be integers. The A has to be a positive integer. All right? So, and it's got to be perpendicular. All right? That's a key word right there. All right? To this graph. So I want to find a line that's going to look like this and is perpendicular to this graph. Well, if they're perpendicular to each other, what's the really important thing to know about? It's going to be that my slope is going to be the negative reciprocal of the slope that they give us, okay? So let's find the slope that they give us. So I do that by putting it into slope-intercept form. All right, divide by negative 9. So what is the slope of the line that they give us? It's positive 4/9, isn't it? So what is the slope of the line that I'm going to try to find? The perpendicular slope. It's negative 9/4. Okay, so that's pretty important. All right, I'll put it in a little box to show that we're going to use that a little bit later. Okay, it's not my answer, but that's what we're going to use a little bit later. And then now what can we do? Well, I've got a slope and I've got a point. So if you wanted, you could use point-slope form. Or if you wanted, you could keep the slope-intercept form, right? We're kind of used to that. And you could put that in for the x and that in for the y, solve for y. You could do that, all right? Did anybody use the point-slope form on this? Nobody? We did? Okay. So let's do that. You don't have to. You could have used what we did earlier with the slope-intercept form. So let's do that. It's y minus y1. I'll just write it down. Y minus y1 equals m times x minus x1. Okay? All right, and let's plug the stuff in. So this is my x1, and this is my y1. All right, so it's going to be y minus y1, which is negative 15, which will be what? Plus 15, equals the slope of the line that I'm trying to find, which is negative 9/4, times x minus x1, which is 12. All right, slide this up here. You know what we could do right away? Did I do that? It doesn't matter. Let's do it the way I was going to do it originally. So this would be what? Negative 9/4 x. Then negative times negative is positive. What happens here? This is a 12 on the top, a 4 on the bottom. So that 4 cancels out with that 12, what? 3 times. So that would be what? Negative 9 minus, I already got the plus there, so that would be what? 27? Yes? Okay. And is that the way I did it? Did I do that right? Okay. Because I don't remember going. Yeah, I think the way, let me see. Let me just. Oh, yeah, okay. Here's what we did. I'm sorry. Okay, so I want to get rid of that 4, but I'm going to do this first. I was thinking about multiplying everything by 4 right now, but that'll make it too difficult. So I'm just going to subtract a 15 from both sides. And so I get y is equal to negative 9/4 plus, what's that, 12? Okay. Oh, 9/4 x, sorry. Can I leave it like that? That's slope-intercept form. But no, they wanted it in what? Standard form. So I don't like that fraction. All right, so let's, first of all, let's get rid of the fraction right off the bat. So how could I do that? Multiply everything by 4. So if I multiply that by 4, it'll go away. Then I got to multiply that by 4, and I have to multiply that by 4 as well. Correct? Yeah. And then let's do this. Let's move everything to the left-hand side, right? Because I want everything equal to 0. I already got the 4y there. I just got to move this negative 9x to the other side. So there's a 9x. 4y is already there. It was positive 4y. And let's take this plus 48, right? That's going to be a 48. Move it to the other side. That gives me a negative 48 equals 0. And there you go. That's the standard form that's perpendicular to that line. So this line right here and this line right here are perpendicular to each other, and this line goes through that point. Yes, sir. Write a pass. Just come up and get a pass. Don't even ask me if you have to go. Just come up, write a pass. I'll know exactly what you're doing. All right, let's do this one. It says graph this thing right here. It's absolute value. So what does an absolute value look like? Looks like a V, doesn't it? All right. And what is this minus 5 doing to that original absolute? It moves it to the right. If it's inside the absolute value, it moves it left or right, and it moves it in the other way that you would think it would move it, right? So it looks like minus 5. You would move it to the left, but you're actually moving it to the right. All right, so that's our starting place. And that would be one, well, let's make it a little easier to see. So 1, 2, 3, 4, 5 right here. And what do we do for the rest of it? Didn't have much room here, did you? But you know the line's going to go up like this. It's going to go like this. And then we connect them. Now, is this one of those ones where you shade or you put a dotted line or anything like that? No, why not? Because it's equal to, exactly. All right, so we just go like this. And then we go like this. Yep, pretty good. And if you wanted to be really particular about it, you probably should put some arrows on the end. We're good to go. All right, let's do the next one. What about this one? This is that greatest integer function. What does that plus do to? This is that step function, right? What does the plus 2 do to that step function? Right, instead of starting at 0, 0, where does it start? At 0, 2. Then what does this thing do? It goes to the next integer, and then it's open. Then it pops up, it goes to the next integer, pops up, goes to the next integer, and so on. All right, and you could do it this way too, couldn't you? And you should, just show variety like that. And you can keep going if you wanted. All right? Most of you got those, right? Some of you went the other direction. Some of you started with an open circle and you went to the closed, all right? But you start off with the closed, you go to the open, and that's what we do. All right, what about this one right here? This caused a little bit of confusion. So what I'm going to do, this is a compound inequality, so what I'm going to do is I'm going to split them up into two. I'm going to go -4 less than or equal to x minus y. And then I'm going to do this. I'm going to go x minus y is less than or equal to 5. And I'm going to find the equation of the line with both of these. All right, and I'm going to graph it right here. So let's get y by itself. I'll tell you what, let's add the y to this side. Is that all right? Then add a 4 to this side. Do I have to change the inequality in that situation? No. So that's x plus 4. All right, so that's the one thing I'm going to graph. What about this thing? Let's move the x to the right side. So I've got -y is less than or equal to -x plus 5. But I don't want the -y, I want a positive y. So multiply, right, or divide, either way, both sides by -1. That gives you positive. Now I multiplied by a -1, so what do I have to do to that inequality? I got to make it greater than or equal. And I got to multiply everything here, or divide. It's the same thing if you're using 1. So that would be a positive x minus 5. So those are the two things that we're going to graph. Now, these are inequalities. So this is where we have to do some shading. Both of them are or equal to, so that means we're going to have a solid line. All right, so that's kind of nice. 1, 2, 3, 4. The slope is 1. So instead of going up 1 over 1, see how short that distance is? Maybe I'll go up 2 over 2, go down 2, right, go down 2. Everybody get the idea? So it just stretches it out a little bit, makes you a little bit more accurate. All right, there you go. Let's do this one. We'll worry about the shading in a second. Let's do this one. Y-intercept is -5. 1, 2, 3, 4, 5. And the slope is still the same thing. So what's true about those two lines then? All right, I'll really stretch it out a lot. I went up 5 over 5, right, just to make it, again, a little bit more accurate. Because if you only go up 1 over 1 and that's it, sometimes your line might not line up perfectly. All right, so that's why I do that. All right, now what about the shading? This x plus 4 one, it says it's less than, all right? So you're going to shade below. This one is greater than, you're going to shade above. What if you forget whether you shade above or below? What's a good way to do this? Pick a number somewhere. You could pick one on this side, in the middle, or on this side. 0, 0 is by far the easiest one to do. So if you put a 0 and a 0 in for this, that's a 0. Would you agree? So is this a true statement? Is -4 less than 0? Yes. Is 0 less than 5? Yes. So do I shade? Yes. That's inside, so I shade in between. Okay? All right, one more. Absolute value, inequality. 1, 2, 3, 4, just like we did earlier. The slope is just a 1, so I'm going to go up 1, 2, 3, 4, 1, 2, 3, 4. Then it's going to be the same thing over here. Now, do I take a solid line and just connect them? No. Why? It's just greater than. It's not or equal to. So it's a dotted line like this. Wasn't super accurate, but you get the idea. Okay, so there it is. Now, it's greater than. So again, what do? Pick a point, all right? Pick a point. Pick 0, 0. Put a 0, 0 in for this. So is 0 greater than 0 minus 4, which is -4? Is that true? Yes. So what do we have to do? You got to shade. So the solution is like a whole bunch of answers, all right? It's not just one answer. It's all the things, all the points that lie inside of there. Pretty good timing, wasn't it? So test on Monday. Be ready for it. This will be online, so feel free to check it out. Should be good grades on this. This is all stuff we did in Algebra 2. There's rarely anything on here. Is there really anything that we've done that's new? I don't think there is anything that's new that we didn't do last year. All right, so it's just review. So hopefully you'll start off with a good test grade.